Hey, it's Chris. We're taking a look at 35 and 36 here in section 4 of SAT practice test 4. So for question 35, they give us this equation at the top, and then they say that dynamic pressure Q generated by a fluid moving with velocity v can be found using the formula above, where n is the constant density of the fluid. An aeronautical engineer uses the formula to find the dynamic pressure of a fluid moving with velocity v and the same fluid moving with velocity 1.5 v. What is the ratio of the faster fluid to the slower fluid? So basically what we're looking at here is we want this dynamic pressure, or Q, of the faster one to the slower one. So basically it's fast over slow. Okay. Well, we know the formula 1/2 NV squared is going to apply for both. And so here for the fast one, it says it has this velocity of 1.5 v. So we're going to use this same formula that they give us. It's 1/2 n times 1.5 v squared. And then the slower one will be 1/2 n times v squared, as it's originally written. And the nice thing about these ratios, they look really complicated at first glance, but don't be intimidated just because you have these somewhat complex looking terms in these fractions when you set up your ratio for these kinds of questions, because most of it will cancel out, almost all of it, and we'll see that happen here. So the 1/2s cancel, the n's cancel, and we just have to square that v term on top. So when we do that, this is going to be 1.5 squared, which is 2.25, and then times v squared, and over v squared. So if we look, even those v squareds cancel, and at the very end, we're left with 2.25 to 1, which is really just 2.25, and that's what we can bubble in for our answer here on 35. So again, at first glance, you may be looking at a rather complex looking equation, but when you have these, I call them adjusted variable ratios. That's just my own name that makes sense in my head. But basically, you're adjusting one of the variables by some sort of multiplier. It's twice as much, or 3 times as much, or half as much. And then you're comparing how that's going to impact the resulting value. And so when you do that comparison, just remember that anything else in the equation that's not changing, anything else that is a constant, can cancel out, which means even in your original setup, if you really wanted to, you could just flat out ignore those things because you know they're going to cancel in the ratio. So our answer to number 35 is 2.25, and now we can move on over to number 36. And here it says, in the figure above, the circle has center O and has radius 10. All right. And they say if the length of arc AB right here is between 5 and 6, so it's somewhere between 5 and 6, what is one possible integer value of x? So when you're given a range, and I know we've talked about this on other questions, so if you've been watching our full video series, then you're probably already familiar with this, but basically when you're given a range of values, the easiest thing to do, a lot of people's instinct is, well, why don't I just pick a number in the middle of that range? And let's say I try 5.5, and then I do all the math on that. Well, that doesn't guarantee that you would come out with an integer value of x. So usually with a range of values for a grid in question, you want to solve both. You're going to treat this as if it's two separate problems. What if the arc length was 5? And then separately, do a separate calculation altogether. What if it was 6? And then your resulting values, that will tell you the range of possible answers that you can input. So let's see how that works here. So with arc length and degree, so x is a degree, and your degree for a circle is always based out of your total, which is 360. And your arc length, we'll start with 5, is based out of your circumference. Because, again, for a circle, the entire distance around is your circumference, and that's also representative of 360 degrees. So here, your circumference is 2 pi r. And we should know that. If you don't, they do give it to you in the cheat sheet at the beginning of the section, but to me, that's a must memorize formula for circumference. I'll put that up here and highlight it just as something to take home. Your circumference of a circle is 2 pi r. And then this would be our setup to solve for the degree measure associated with an arc length of 5. And now we're going to do that same exact setup. X over 360, so it's your degree relationship, degrees over degrees, equals arc length over circumference. Oops, I put 5. For that one, I meant to put 6. So you should, again, solve for both ends, right, of that range, the 5 and the 6. And so this would be 2 pi times your radius of 10. And now for each of these, we're just going to cross multiply and solve. You can, cancel out where you're comfortable or reduce where you're comfortable. I'm going to assume that because this is calculator section, you are, going to be able to do this calculation using your calculator, and hopefully won't run into too much trouble. But if you have questions on the steps, just please leave a comment. I'm happy to, walk you through it in more of a stepwise fashion. But here, this is going to be 20 pi times x equals 1800. And then here, this is going to be 20 pi times x equals 2160. And if you divide each of those by 20 pi, you'll get x equals 34.4 degrees. And then over here, you'd get x equals 28.66 degrees. And so any integer value in between those, you could bubble in 29, 30, 31, 32, 33, or 34 for your correct answer.